Hello, students. Welcome to Engineering Geology and Hydrology. Today, we're going to explore Chapter 3 on fold structures. So, what are fold structures? How do we identify them in the field? We will focus on four main aspects today. First, the definition of fold structures. Second, the basic types of fold structures. Third, the morphological elements of folds. And fourth, the causes of folding. First, let's see what a fold is. Students, take a look at these two photos. Can you spot any differences? On the left, we have normal rock layers, formed by sedimentation, which are essentially horizontal. But looking at the right photo, have the rock layers undergone severe bending? Why is there such severe bending in the rock layers of the right photo? Well, this is closely related to what we're learning today, folds. A fold structure refers to a series of undulating bends in the rock layers that make up the crust under the influence of tectonic stress without losing their continuity. We call this a fold. The right photo shows the process of fold formation. We can see that when rock layers are horizontally compressed, they undergo a series of undulating bends. Thus, we can call this geological phenomenon a fold. Next, let's look at the two main aspects of fold structures. The basic types. During fold formation, there must be a phenomenon of the rock layers bending upwards or downwards. We call the one with the rock layers bending upwards, and the core area having older strata, and the sides gradually becoming newer and anticline. Conversely, when the rock layers bend downwards, with the core area having younger strata, and the sides gradually becoming older, it's called a syncline. Anticlines and synclines are the two basic types of folds. At the beginning of fold formation, anticlines often form mountains, and synclines form valleys. However, due to continuous weathering and erosion, it is difficult to retain these topographical features. Therefore, we cannot judge anticlines and synclines solely based on whether they are mountain or valley topography. In this case, we need to identify them based on the morphological characteristics and the laws of change in the rock layers. The outcrop characteristics of anticlines on the ground are that from the center to both sides, the rock layers symmetrically reappear from old to new. Conversely, for synclines, the rock layers, from the center to both sides, symmetrically reappear from new to old. So, how do we identify anticlines and synclines in the field? First, we must determine whether it is a fold. If the strata symmetrically reappear around a certain center, then it is definitely a fold. Then, based on the age relationship, if the center is old and the sides are new, it is an anticline. If the center is new and the sides are old, it is a syncline. Here are some photos of folds in the field. We can clearly see that, due to engineering development and slope construction, we have encountered a fold. On the left, we can see the rock layers are bending downward. It is a syncline. On the right, the rock layers are bending upward, so we can determine it is an anticline. There is also a large syncline structure, and we can clearly see that the rock layers are bending downward, so it is a syncline. This photo is quite typical. Can you tell which one is an anticline and which is a syncline? On the left, the rock layers are bending downward. Although the high point on the left is higher than the high point on the right, we can see that the left is a syncline structure and the right is an anticline. So why is the high point of the syncline structure on the left higher than the high point of the anticline structure on the right? This is what we just mentioned. The right side's anticline has been eroded, and the upper part has been eroded away. Therefore, the high point on the left is higher than the one on the right. Third, morphological elements of folds can be divided into the core, wings, hinge zone, axial plane, and hinge line. The core refers to the rock layers in the center of the fold, which is the red part in the upper right corner. Our core. As we just mentioned, the core of an anticline is the older strata, and the core of a syncline is the younger strata. The wings refer to the rock layers on both sides of the fold's core, which we call the wings. The hinge zone refers to the part where the rock layers of the two wings of the fold transition and bend, which is the part B in the upper right figure, which is our hinge zone. The axial plane refers to the imaginary symmetrical surface that roughly bisects the two wings of the fold, which is the surface EFGD in the upper right figure, which is our axial plane. Our axial plane can be a flat surface or a curved surface. The hinge line refers to the line where the same rock layer in the fold intersects with the axial plane, which is line BL, and can be called the hinge line of the fold. Fourth, the causes of fold structures require some thought. What mainly causes fold structures? The causes of folding are mainly three aspects. The first is the action of horizontal lateral pressure. When our rock layers are subjected to horizontal lateral pressure, they will undergo a series of undulating bends. This cause is the most common type we see in the field. The second is the action of vertical force. When the rock layers are subjected to a vertical upward force, the rock layers will also bend and form folds. The third is the action of a force couple. When our rock layers are subjected to a pair of equal magnitude, opposite direction, and parallel forces, they will also bend and form folds. This kind of cause generally forms our overturned folds or recumbent folds. In this class, we mainly learned about the four aspects of fold structures. First, the definition of fold structures. We need to understand what fold structures are. Second, the basic types of fold structures, which are anticlines and synclines. Third, the morphological elements of folds, mainly including the core, wings, hinge zone, axial plane, and hinge line. Fourth, the causes of fold structures, which are the action of horizontal forces, vertical forces, and the action of couple. Next time, we will study a more important content in geological structures, fault structures. See you next class.